Yep, I am live. Uh, let me check. Yep, I am live. So today, yesterday, we left about 4 questions, and today we are going to do them. We were facing some problem during the fourth last question, but today it gets solved here. We did question number 20 perfectly good. Now we have to do question number 21. We had to replace individual spaces, by either tabs or blanks. We had to replace blanks by either tabs or blanks to produce the same number of apparent spaces. So let's do that. Okay, yep, I'll just go to the folder where I write my C codes, and yep, the program which we were working on was called replace blanks uh, uh, with replace space space shit, is the repal space with the min tabs. This was the function the, that we wrote yesterday, and this contains bugs. Now we have to fix them. So here in this loop we are getting one character by character, every character one by one. Now we want to count, first of all, the amount of tabs and then the amount of spaces. When getting a character, we know at which position it is in a tab space. Tab space is 8 uh, tab space is 8 spaces long, and this tab index tells me the tab index of the current character, and it goes from 0 till 7. I made a mistake, it seems. I am starting this at 0 here, and then for the first character I am getting 1 instead of 0, so I should be getting 1 instead of getting 0. I can fix that by doing initializing tab index equal to -1. Then for the first character I will get 0, and okay, this would fix things for the tab index. Now tab index gives me the index in the current tab space for the current character. Now if I have a space, this space could either be the first space or um the first space, and the last one could have been a character. This space can be a space which comes after a character, or a space which has a space before it. And what would I like to do? First of all, I will just increase the number of blanks, and tab number is, do I want a tab here for this space? And this is only increased if the tab index is 7. That is, the current space is at the last index for a tab. Yep, and the current space is at the last index for a tab. So now I want to see, am I getting the correct tab number? If I am getting the correct tab number, Then I can just print those tabs when I get a character. If is for a space and else is for characters. And before putting the character, I have to put the required number of tabs and spaces. And I will see if blanks is greater than 0. That is if I have any blanks to print. Okay, I can see the problem now. I do actually see the problem. Here, I think printing tab is good. It is working correctly as I would like it to do. But here, printing tab index is not working correctly because let's say I only got a single space. So, and after that space, I have tab blanks equals 1. And then uh, if that space is the last space, if that space is the last space in the tab index, in the tab space, then it will also increase the tab number. Thus, I will print a tab number and then I will also print blank spaces, which is not good. Yep, it is not good. What would I like to do? Hmm. Yes, what would I like to do? I would like to see, yeah, if it is a space, then instead of increasing tab number, I can just print a tab. And yeah, that would, I guess, make sense. If tab index equals 7, then put char tab, and I can remove this. Okay, this will put char tab, and this will make blanks equal 0, and else if we are not at a end point, then blanks will increase by 1, and here I will make not tab number. I do not need this code anymore. Here I can, instead of doing it for tab index, I can do it for blanks, and here I can even remove tab index. No, not tab index, but tab number. This should work. First of all, move replace and into replace space with minimum tab dot c. Client replace space with minimum tab, and output should go to dot out. Let's see. As function, yep. It works. It works. It works. So now we fixed this. That is pretty cool. How much time did it take us? 9 minutes. That is good. Maybe there was, of course, some overhead, so 7 to 8 minutes. That was okay. Okay, that was okay. We already had the program written. We just had to make changes. It was just fine. Write a program to fold long input lines into two or more shorter lines after the last non-blank character. Okay. Write a program to fold input lines into two or more shorter lines after the last non-blank character that occurs before the nth column of input. Make sure your program does something intelligent with very long lines, and if there are no blanks or tabs before the specified column. Okay, fold lines dot C. What would I like to do? Write a program to fold lines uh, into two or more shorter lines. First of all, the part that we always have to write main, and I will I have a character, and do I need something else? I don't think we would need anything else, do we? Well, we will see. C equals get char is not equal to end of file. Then do this. Fold lines into two or more lines after the last blank space character that occurs before the nth column of input. Nth column of input, and one column means I'm supposing character column of input. Nth column of input. By column of input, I am supposing that they mean character. Brian Kernighan, man. Okay. Make sure your program does something intelligent with very long lines. Okay, let's write for this much part. Define macro. Length. Let's call it length, and let's say 100 characters. That is the maximum amount of characters that we would like to have. If space, no, not if space, if C equal to space, then do something, and yes, you would need a integer like this. Yep, it would start with 1, and if you have a space, no, not a space, but you would keep checking if I want last non-space character. So I cannot directly print, right? Yep. I can only print a word in a line if I know that printing that word on that line will not exceed the length limit for that line. So I will also need an array, character word array. Let's say its length will be 100 words. So I can, well, surely increase character length for a line. This will contain the words. Now I need two counters. One that will keep count of, I need two counters. One that will keep count of the uh, length of the line, and one that will keep record of the number of characters in a word. Okay. Now we would like to see what C equals to a blank. If it is a blank, then either yes, then I ended a word. right? And I can suppose that I have a word in the word array, and I is the index in the array at which we had put the last character. So now at word I, not where we put the last character, but where we have to put the next character, we can make it null, and then printf that character here by providing this, and then yes, and I then equals 0, and okay, this will print the word and reinitialize it to 0. And I only want to print a word if it does not exceed the length. If length plus I less than length, do all of this, only then, right? And if the current word, okay, and yes, length equal to length plus I before this, and else, that is, if by printing this current word on the line, the length of the line surpasses the maximum length, then I will first put a new line character so that I am at the new line, and then print the character. Printf %s word, and yes, the same thing. Nope. This thing also, and I is also equal to 0, and length will also be equal to 0. Now else, if the current character is not a blank, then put word I equal to C, put it in through the character, and I plus plus. Is there anything else I would like to do there? Nope. Up. Now this should work. Blank fold lines. Output should go to out. Well, it compiles. I think 500 characters is a pretty long. Uh, okay, we messed up somewhere. Let's make this 100, and let's try to do our magic now. Okay, segmentation fault. Okay, segmentation fault. What the fuck? Why am I getting a segmentation fault? Segmentation fault. Word yes, I did not initialize. I equal to length equal to 0. lang, and then oh yes, of course I have to also print the space. Goddamn, yeah. For where is fold line here. If I have a space, then before printing the new character, I have to print a space. Put char space. Oh, my bad. There seems to be some problem here. Yep. This is not a function. Fold lines. Here, first of all, I will be printing a space after the characters and new line, and then moving on. What if I have a new line? If I have a new line, yep, then I can just print it. If I have a new line, then I put char new line and length becomes 0, and I also becomes 0. This should work. It got folded and the spaces are also good. It works. So we did question number 22. Now moving on to question number, no, wait. You have to make sure your program does something intelligent with very long lines. If the lines are very long, what is the best intelligent thing that our program can do? If the lines are very long, then they will be treated. I think this is the more intelligent way. Printing word by word. That is pretty intelligent, I guess. And here, make sure your program, yes, and if there are no blanks or tabs before the specified columns, if there are no blanks or tabs before the specified column, then what will my program do? The one I have written. It will just print the line on the next line. So that is stupid. What can it do? It can, if that happens, if that like actually happens, then let me check for it. If I have length of the character in the ith character. Wait, first of all, I will print a new line. I guess yes, I should print a new line. And yeah, okay. If I greater than length. That is a damn as long word. If that is the case, then I will write some logic for that. But if it is not, then these things will happen. Wait, and but some of these things will happen no matter what. So let me do that. Yep, like that. And here, I know that the word I have is too big to be printed on a single line. Then I would like to chop the word off. Yep, chop the word off and print the chopped word line by line. Shit, okay. And I am supposing the maximum length a word can go. Well, in our program it will not happen because the maximum size of a word is lower than the maximum size of a line. But let's say it does happen and it is 400. A word can be 2 times longer than a line. Then I would like to print the first 200 characters at one line and the next 200 characters in the second line. And for that, I will do character temp equals word 200. I will take that, and word 200 equals new line, and one more thing, not new line but null, and then print %s word not print but printf, and then put it back, word 200 equals temp, and word 400 900 399 equals null character, and yes, after this, yeah, yes, here I can give it a new line character, and then yeah, that is it. And then here printf %s and new line, and give it the address for 200 character. The address like this. We got our second program for the day working. Now moving on to the third program. And how much time has it taken us? 28 minutes. That is quite a bit of time. 20 minutes to spend on this single program. Now write a C write a program to remove all comments from a C program. Don't forget to handle quoted strings and character constants properly. C comments don't nest. Write a program to remove all comments from a C program. Okay. Don't forget to handle quoted strings and character constants. Okay. To handle quoted strings and character constants. How do we comment in C? C comments are like this. Okay. I got this. We can remove this. Yes, let's write a program that removes comments. remove comments.c, and here we have first include stdio.h, then in main. Here I will have integer c, which will take input to remove all comments from a C program. Okay, and I am supposing that I will be getting input from using the get char function. Okay, while c equals get char not equal to end of file, I will be getting in I can do that what they did. Define it in as 0 and define out as 1. State and initial state will be equal to out. Now let's see if I want to see two characters at a time. Now if c equals this slash if c equals slash. Now I would like to see if the next one, and I am supposing that when I see a slash and a star, that will be ended by a star and a slash, that the person is not bluffing. Let's see, does that create a comment? That does create a comment, it seems like. Nope, that does not create a comment. Okay, first of all, shit. Let me write a program that just clears comments. If this is C is this, and then let's say char next equals get char. I am getting the next character. If next equal star, then state equals in. That means I am inside a comment. And if not, then put character first of all C, and then put character next. Right? Yep. And else if C equals star. Now char next equals get char. If next equals, that is the comment has ended, then state equals out. And if it is not the case, then I will just print them. put char next, and else I will see if out, no, if is state equals out, then put char c. Clang remove comments card slash out. That's something. Then I will write a comment like that, and then comment end. Yep, I did not get the things inside the comment. That is good. There can be edge cases like what if C comments don't nest, but the thing is that what if someone starts a comment and does not end it, then I would have to have a record of all these characters that were inside the comment, right? Yep. Now that would only happen supposing that there is an improper syntax in the program, but I am supposing that the program is syntactically correct, and I will only see these characters stand alone inside quotes as a string. So we should handle the case for strings, that is comments inside a string are not counted as comments. So state comment. I will have two states, one for comment and one for strings. Comments and comments. Okay, and another state. I got it. Yep. State string. This will also be not comment but state string equals out. This will also start at out. Before doing that, let me do else if some condition, and here what is the condition? C equals this, C equals a single quote or character equals a double quote. Okay, this and double should do it. Comparison between pointer and integer and comparison between pointer and integer. What is a pointer? Pointer is, I do not have a string. Okay, I should not provide it a string. Shit. What is the character code? Okay, I can do this, I guess. No, not this, but this. Yeah, this works. Yep, this works. I'm looking if C is a single quote or a double. I only have to check for double quotes. Single quotes don't mean strings in C, at least not in C. So deleting that. If I have that, a string state will just switch, become opposite of to what it currently is. But what if this string is inside a comment? Ah, ah, ah. Okay, if state comment equal to out, only then state of a string equals the opposite. If it is in, it will become out. So if state string equals out, then it will become in, otherwise it will become out. And this will only happen if I'm not in a comment. And here all of this bullshit that happened, this will only happen if I am outside uh if I am outside a string. If state string equals out, do all these only then, and else if it is in, then just put the character, just put C. And same goes for you. If state string equals out, uh, do all of this only then, otherwise else just simply put the character, the current character. Yep. And if comment is out, then print it. Either comment has to be out. Yeah, if comment is out, comment is out. Yep, if comment is out, only then print it. Lang and dot slash out. Yes, stream is working perfectly. And let me first write something, start a comment, write something inside the comment, end the comment, and then start a string, write something inside the string, add a comment inside the string, close the comment inside the string like that, write something, end the string, and then let's start a string and end it. Okay, I did not got all of this, which was a part of the comment. It started printing from here, and yes, all of this got printed. FLK, FLK, and then okay, the quotes for the strings were not printed. These, okay, remove comments. When I have these strings quote, then if I'm outside the comment, then put char C lang and do it, and as function, yeah, it works. Now we did question number 23. Now question number 24. Write a program to check a C program for rudimentary syntax errors. Okay, like unmatched parentheses. Yes, that can happen. That can happen. Brackets and braces. Okay, don't forget about quotes, both single and double. Escape sequences and comments. This program is hard if you do it in full generality. Okay, right, for rudimentary syntax errors. Let's add that syntax error checker dot c include stdio.h int main, and I would like a few things. I will only be checking for, there are two things, two states that I want to keep in mind. For, well, first of all, I would like to have a integer c and state of comment and state of a string, and two, what are these called, what are these values called which we define by define, what are the values which are defined in C with hash define called macro expressions, directives, macro expressions. Okay, these are something that is handled by the preprocessor. Define out means 1, and define n means 0. Nope. Yes, this sounds more better. Yep. State string will start at out, and state rec state comment will also start at out. And yes, I am streaming properly. Then I will be getting the character using get char function, end of file. Okay, now let me do this for parentheses. Well, here I can copy uh, for comments, the code I wrote for comments. All of this will be necessary in here, like that. Like that, and all of this code checks for this part, this whole part from here till here, checks for comments and handles that logic, and this part here handles the string logic. All I have to do is add other conditions here. Is let me make this more beautifuler. Yep, that is more beautifuler. Else, let me add other conditions, like else if c equals a opening parentheses. Whoa. Oh, if c equals opening parentheses, that is if I have a opening parentheses, then what would I like to do? I would, no, at the end of the program. This will happen at the end of the program. Yes. 18 integer count open param count close. param. For the function to have the correct syntax, the open param and close param have to be equal. Now, then brackets and braces. Okay, count of open brackets, count of open, not open but close brackets. There was a scientist named Bracket. Oppenheimer tried to kill him. Uh, braces, like tooth braces, braces. Yeah, let me check for them. 36. Instead of doing this here, I can do this here. Before putting the character, I would like to see if C equals open bracket, then open count open param, not param, should be paran, parentheses for paran, and also initialize all of them to 0. So count open param equal count close param equal count open braces equals count close braces equals count open brackets equals count close brackets equals 0. Initialized all of them to 0 and replace, fix this. Now if else if C equals close param, then count close parentheses plus 1, and else if C equals open bracket, then count open brackets plus plus, else if C equals closed bracket, then count close bracket plus plus, else if C equals open brace, then count open braces plus plus, else if C equals count close braces, then count close braces plus plus. This should do it. This should be enough. Yep. And after printing all of them, I'll see in the end after my while loop, that is if it is straightforward, if open count open paran is not equal to count of close paran, but shit, I fucked up here. Whenever I see open and close params, I am increasing this, but I will only increase this if I'm out of the comment, and yes, I am out of the comment. So yeah, that is good. If it is not equal, then I do printf in the num syntax regarding the parenthesis is wrong, you retard. That should not be offensive. Now, if count of open braces is not equal to count of close, not parentheses, but not equal to the count of close braces, then syntax regarding the braces is wrong, you retard. And then if count of open brackets is not equal to the count of close brackets, then printf copy paste, of course, cats brackets is wrong. Okay, and now this will work for brackets, parentheses, and braces. Don't forget about quotes, both single and double, escape sequences, and comments. Escape sequences are okay. I do not have to worry about them. How can they be syntactically wrong? Comments I am also handling. Then single and double quotes. Okay, that is handleable. Okay, single and double quotes. There are no opening single quotes and closing. They are both the same. So I will have to see if their count is even. They have to be even. So single quotes and double quotes count. Make them also equal to 0. Single quotes equal to double quotes equal to 0. Now I have already written for double quotes. If I'm out of a comment, then with this I will also do double quotes plus plus, and here I can handle the case for single quotes here. Else if c equals backslash single quote. If I have a single quote, then single quotes plus plus, and with these conditions I can add additional conditions for single quotes remainder by 2 equals 0. This has to be 0. If it is not equal to 0, then I will print the error message, which is this: regarding single quotes is wrong. And then if double quotes remainder with 2 is not equal to 0, then let me print the error message. Seems like we did it. Clang, not remove, but syntax error. Output should go to the dot out. Okay, I wrote something and I opened a quote, opened another parentheses, and did something, and Then inside of a comment, I closed that bracket which I opened earlier and did this. And yes, at the end of the program, regarding the parentheses is wrong. Yep, but also I need to print new lines after that. Backslash and backslash and here also backslash and that is done. So chapter number 1 is completed with all of that. Chapter number 1 is completed and we did that in 1 hour. Now we have one more hour for chapter number 2 and let's see what is in chapter number 2. But before that, I have all these programs from chapter number 1. I will put them in a separate folder called chapter number 1. Let me make now make there make a directory called chapter 1 and move everything that ends with .c into chapter chapter 1 ls chapter 1. All the programs are inside chapter 1. I can remove dot out and out. But yeah, and what the heck is v actually here it is. What the heck is this? This contains some file names. I can just delete it. Yep, chapter number 1. Now, chapter number 2. What does this contain? Types, operators, and expressions. What are all these? And see. Starts at page number 35. Variable names. Then we have data types and sizes. Then we have constants. Okay, quite a few constants. Declarations. Arithmetic operators. Relational and logical operators. Type conversions. Increment and decrement operators. Increasing and decreasing bitwise operators. That is also cool. Assignment operators and expressions. That is cool. Conditional expressions. Cool. Precedence and order of evaluation. Cool. And then the end without any questions, it seems. The question is whether the subscript and this. Okay, precedence doesn't have any questions and every other segment has some questions of its own. It is started at page number 35 and till page number 51. Thus we have around 15 pages for this chapter. So let's have a target to complete till here, till this part today. That is shit. That is this much. Okay. Move, sucker. Let's see. Chapter 2, types, operators, and expressions. Variables and constants are the basic data types. Variables and constants are the basic data objects manipulated in a program. Declaration lists. Okay, variables and constants are the basic data objects manipulated in a program. Declaration lists. The lists list the variables to be used and state what type they have and perhaps what their initial values are. Operators specify what is to be done to them. Expressions combine variables, types, operators, and expressions. Expressions combine variables and constants. Expressions combine variables and constants to produce new values. Variables and constants to produce new values. The type of an object defines the set of values it can have and what operations can be performed on it. These building blocks are the topics of this chapter. That makes sense. Yep. The ANSI standard has made many small changes and additions to basic types and expressions. There are now signed and unsigned forms of all integer types, that is 32-bit, 16-bit, I guess, integers, and 64-bit integers, fraction integer. Well, fractions are not integers. There are now signed and unsigned forms of all integer types and notations. Wait, why am I passing out, spacing out? There are now signed and unsigned forms of all integer types and notations for unsigned constants and hexadecimal character constants. Okay, floating point operations may be done in single precision. There is also a long double type for extended precision. Okay, the string constants may be concatenated at compile time. Okay, enumeration have become part of the language, formalizing a feature of long standing. Objects may be declared const which prevent them from being changed. The rules for automatic coercion among arithmetic types. The rules for automatic coercions among arithmetic types have been augmented to handle the richer set of types. The rule for automatic coercion among arithmetic types have been augmented to handle the richer set of types. Okay, so single arithmetic operator can be used for different data types automatically. You do not have to do anything. Although we didn't say so in chapter 1, there are some restrictions on the names of variables and symbolic constants. Names are made up of letters and digits. The first character must be a letter. The underscore counts as a letter. It is sometimes useful for improving the readability of long variable names. Don't begin variable names with underscore. However, since library routines often use such names. Upper and lower case letters are distinct, so small s and capital S are two different names. Traditional C practice is to use lower case for variable names and all uppercase for symbolic constants. Symbolic constants whose values are symbolized in the start of the program with hash define. At least the first 31 characters of an internal name are significant. Okay, for function names and external values, the number may be less than 31. At least the first 31 characters of an internal name are significant. For function names and external variables, the number may be less than 31 because external names may be used by assemblers and loaders over which the language has no control. For example, for external names, the standard guarantees uniqueness for 6 characters and a single case. Keywords like if, else, int, float, etc. are reserved. You cannot use them as variable names. They must be in lowercase. Okay, it's wise to choose variable names that are related to the purpose of the variable and that are unlikely to get mixed up typographically. We tend to use short names for local variables, especially loop indices, and longer names for external variables. But what does this mean? At least 31, at least first 31 characters of an internal name are significant. What does that mean? language, the first 31 characters of an internal name are significant. What does that mean? What does it mean? Means even we say that the first 31 characters of an internal variable's names are significant. It means that the compiler considers only the first. Okay. If the name spans longer than 31 characters, then if the distinction between if you have two variable names which are longer than 31 characters and the characters which make them different appear after the first 31 characters, then they will be treated as same. Such a variable or function name declare inside a function or a block. Any character beyond the 31 are ignored when distinguishing identifiers. That makes sense. This is a very long variable exceeding 31 characters and extra 10 and 20 print. This is a very long variable exceeding, and this error same as the first one. What happens? The compiler treats both variable name and variable names as identical because they are 31 character. Okay, what will be the output for this? Error same as the first one. Okay, so this one will also have error. This would lead to redefinition error because I am defining this variable twice here and then at this place. Okay. The first 31 characters of an internal name are significant for function names and external variables. The number may be less than 31 because external names may be used by assemblers and loaders over which the language has no control. Yeah, okay, makes sense. And now data types and sizes. That is interesting. This is easy to learn because we have been studying assembly language. So there are only a few basic data types in C. Char, a single byte, capable of holding one character in the local character set. Integer, 32-bit number. An integer, typically reflecting the natural size of integers on the host machine. Natural size of integer on the host machine can be ranging from 16 bits to 32 bits or whatever. Float, single precision floating point. It takes 32 bits to store a float number, which has a precision of 7 digits. 7 digits. Double precision floating point. Okay. In addition, there are a number of qualifiers that can be applied to these basic types. Short, and long apply to integers. Short and long apply to integers. Qualifiers that can be applied to these basic types. Okay. Short integer, long integer. The word int can be omitted in such declarations, and typically it is. So I can do long and short. Okay. The intent is that short and long should provide different lengths of integers where practical. Int will normally be the natural size of a particular machine. Natural size of a particular machine. Short is often 16-bit long and int either 16 or 32-bit bits. Each compiler is free to choose appropriate sizes for its own hardware, subject only to the restriction that shorts and ints are at least 16 bits, longs are at least 32 bits, and short is no longer than int, which is no longer than long. Short is not longer than int, and int is not longer than short than long. Okay, and int can be 16 or 32 bit. Long, short is 16 bits, and long is 32 bits. at least 32 bits. The qualifier signed or unsigned may also be used, um, may be applied to character or any integer. Unsigned numbers always positive. Yes, and because they are unsigned and obey the laws of arithmetic modulo 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 2 power n, where n is the number of bits in the type. So, for instance, if character chars are 8 bits and unsigned if chars are 8 bit and unsigned char variables have values between 0 to 20 to 25 and signed chars have values between 128 to 127 in 2's complement machine. Yep. Whether plain chars are signed or unsigned is machine dependent. Plain chars are signed or unsigned, it is machine dependent, but printable characters are always positive. Okay. The type double long double takes up long double means double precision, that is 64 bits, and long means long at least 32, so 64 bits would be used. Specifies extended precision floating point. As with integers, the size of floating point objects are implementation defined. Float double is double precision. Long double could represent one or two or three distinct sizes. What is float? Single precision floating point, double precision floating point. Okay, three. Yep. The standard headers limits S, H, and float H contain symbolic constants for all of these sizes. Symbolic constants for all of these sizes. Okay, okay. Along with other properties of the machine and compiler. These are discussed in Appendix B. Now, exercise. Yes. Write a program to determine the ranges of character, short and integer, and long variables, both signed and unsigned, by printing appropriate values from standard headers uh, and by direct computation, harder if you compute them. Determine the ranges of these values, floating point type of the various floating point. Okay, I have to write a program that determines the range of character, short, int. That is doable. That is doable actually. Range finder.c. Um, First include stdio.h and then int main inside there. I will have, and let's say we will start with char c, and I want to find the range for char. Hmm. Okay, while I want to have an infinite loop, and I will be, the idea that I'm going with is that I will keep adding one, I will keep incrementing char c unless it overflows, and when it overflows, I will print the maximum value that I got. So let's say c. No. And I'm looking for a smarter. Oh no, shit. True is nothing. While one. Hmm. Hmm. If, let me check for overflow. If C plus 1 is less than C. That is, C has overflowed. If C has overflowed, then printf range for char is %d new line and give it C. And yeah, that is it. Else C plus plus. And I would also like to have lower range. So after this, can I do break? Nope, not here, but here. Okay, yes, I can break after that. A second while loop. While 1, if C minus 1 is greater than C. When it will overflow, it will become the highest number that it can. Or what will happen? If I keep subtracting, yeah, it will become higher. Greater than C, then printf, that would be, let me move this loop before the other one so that I can print the lower range first. The lower limit for char is %d new line, give it C, and yep, and then move C equals 0 after that, and yep, also break is just C minus minus, and here the upper limit for char is this blank range finder out. Okay, it does not work. It should have worked. Maybe this part is not working. Oh, C equals 0. Let's start it with 0 and comment this out, clang it and run it again. Does not work. Okay, why does it not work when C plus 1 is less than C? Let's keep printing the value of C. Print C with some space and give it C. Clang and run, and we will see a lot of things. Okay, wait, why is it going? Okay, adding. It goes up till 121. After that. After 127, it becomes minus 128, the lowest range finder. Then at that point, I should go into this part. I should Then we print C and also print C plus 1 and then a lot of spaces. C and C plus 1. Okay. If I add 1 to this, I get this, which is greater. Let me find a boundary place around here. Okay, when I add 1 to 127, I get 128. Okay, okay. I think I get it. When I am adding 1 to this thing is getting converted into a integer which can hold the value 128. So here at the time of comparison, I have to type convert it into a character and then compare it. So also will become a character. A character cannot hold that big of a number, and apparently it can. 127. Yep, after 127 I get 128. So okay, let me just use another variable then to store that. C1 C1 and C2, and instead of all this bullshit, let me do if C I will initialize with C1 equals 0, and at the start of the loop I will make C2 equal C1 plus 1. Nope, C2 is all into C2 is 1. So C2 is also 0, and here I will do C2 plus plus. If C2 is less than C1, then print that the upper limit is C1 unless otherwise plus C2. Yeah. And I also have the lower limit print. The lower limit for char is %t plus n C2. And enter run it, and yep, I got the limits for character. Now range finder, let me add code to find the range for other things. Int is I1 and I2, they will start at I1 equals 1, I2 equals 1. This also this will also become I, this will become I, this will become I, and this will become I. And let's see if I can find the range for integers. Okay, that took time because I was incrementing, yeah, but I got the exact value, so that is a plus point. This is not the best way to do that, is it? By getting up, there must be smarter ways to do it. And then I have to do it for short and for long. Limit for not char but int is this, and limit for int is this, and then copy all of this, print it here. Now for short, replace this with s, and this also with s, this also with s, this with s. Find this and replace this with this with this, and replace this with this. Find I, replace this with limit for short, short, short form content short is this, and then the same thing for long. Replace this with long, this with long, replace this with long, 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 oh, long, long, and this has to be changed to L, X, X, LX. This will also be changed to long, or long, and long, and this will also change to. Now this function is going to take quite a bit of time to run. The heck? This will take quite some time to run. Okay, we got for character integer for short. Short is equal to integer. That is good. And then after short we had long, and long is pretty long. That is why it is taking pretty long to get to the highest value. It will take some time. Wait, what if this number, wait, not this, but this number divide that by 128, I get a perfect, like a good number, right? So what if I put this number, the of course the positive for this number, into the long by something like this. When I have, this is the long and this is for long, yep. Instead of initializing this with 0 and then keep adding 0, I can do, when I actually find the number, make L1 equal to S1 plus 1. Yes, S1 plus 1, right? And I will keep adding S1 plus 1 instead of adding 1. L1, L2, S, L1 plus L1, and here is the equation like this will be same. But what the heck is this? Instead of doing this, I will be doing L2 equals S plus equals S1 plus 1. Yeah, S1 plus 1. Yep, S1 plus 1. And here the same thing, and here I will do equal plus S1 S1 plus 1. Now, I'm hoping this works. This like actually increases the speed. Let's see. Oh, that seems to be wrong. Is it though? Is it wrong? It seems to have worked pretty fast. ChatGPT, what is the per side limit for long in C for 64-bit number? This number. No sign. Is it this? Nah, it is not this. Yes, because at the end I would want to add ones. Huh? Hmm. Okay. Here, uh, here when I have reached the end. Instead of just printing them, I will start the loop again. While one, and then start adding one, the one thing. L2 equals L1 plus 1 and L2 plus plus if L2 greater than L1 less than L1, then do all of these things like printing and all that. Oh wait, I can just do this, then actually just break. If not, then L1 plus equal, no, L1 plus plus. Okay, that should be good. I'm hoping it works, that I get what I want to have. Shit. It should not take that long. Literally should not take that long. While true, when L2 becomes smaller than L1, I will break. At this point, L2 is smaller than L1, and then I increase L1 by 1, and then keep incrementing L2. What was the number that it printed before? This number. This. So adding keep Ping adding 1 to this is uh, how to print long decimal values in C. Use printf function, okay. Um, Not float, but long double, long integer, long float. I can specify this is float and use 10 after the decimal places. Okay. Alex, I can do F. Here also I can do F. And now I will get some error. Ah, long. How to print long integer value in C? To print long integer, I do long D. Okay, that makes sense. LD, LD, clang, and then run it. I will be seeing decimal number. Ah, I messed up. I messed up at some point, I guess. Did I mess up here? 64 bits. That is a pretty long number. Adding one and what are the later parts? Is that actually the limit? I thought the sky is the limit. Mm, I can simply use what is provided to me, like the functions that have been provided to get the range values from this and this. Huh. It is just that my algorithm to getting these values is taking quite a bit. It is not wrong. It just takes a long time. Um, just takes a long time. Yep, this is my final submission. It just takes a bit of time, quite a bit of time. Okay, while it is running, let us go move on to the next part, constants. We will let this one keep running in the background. An integer const like 1, 2, 3, 4 is an integer. An integer constant like 1, 2, 3, 4 is an integer. A long constant is written with a decimal L, L, or capital L, as in this. An integer constant too big to fit into an int will also be taken as long. An integer constant like 1, 2, 3, 4 is an integer. Okay, a long constant written with the a long constant written with the L or this, as in this, an integer constant too big for to be fit into an integer will also be taken as long. Okay, unsigned constants are written with terminal u, small or capital, or the suffix ul or ul indicating unsigned long. Suffix comes after. Yep, with a terminal u or u. Okay. 1e2 contain floating point constants contain a decimal point, this, or an exponent 1e minus 2, that is 1 is a value and e minus 2 is the exponent is 2, or both their type is double. Okay, double precision unless suffixed. The suffix f or f indicate a float constant. L or capital L indicate a long double. Okay, the value of an integer can be specified in octal or hexadecimal instead of decimal. A leading zero or an integer constant means octal. A leading zero in an integer constant means octal, that is zero and then a number, that means octal. A leading zero, a leading 0x or 0x means hexadecimal. For example, decimal 31 can be written as 037 in octal and 01f in hex. Is 37 literally 1f? 1 here means 16 and 16 plus 15 is indeed 31, but it is not. It is 037. Okay, that might be equal. 3 into 8 is 24. 24 plus 7 is actually 31. That is good. Octal and hexadecimal constants may also be followed by L to make them long and U to make them unsigned. Full. Here is my hexadecimal number. Hexadecimal digit is just this. This much specifies that this is hexadecimal, and UL specifies unsigned long is an unsigned long constant with a value of 15. A character constant is an integer written as one character with single quotes is an integer written with one character with single quotes such as x. The value of character constants is the numeric value of the character in the machine's character set. For example, in ASCII character set, the character constant 0 has the value 48. Yeah, okay, which is unrelated to the numeric value 0. If we write 0 instead of a numeric value like 48, that depends on the character set. The problem is independent of the particular value and easier to read. Character constants participate in numeric operations just as any other integers, although they are most often used in comparisons with other characters. Makes sense? Quite a bit of sense. Certain characters can be represented in character and string constants by escape sequences, like new line. Certain characters can be represented in character and string constants. Certain characters can be represented in character and string constants by escape sequences. Certain characters can be represented in character and string constant. Yes, by escape sequences like this, like new line with these sequences look like two characters but represent only one. In addition, an arbitrary bite-sized bit pattern can be specified by this, where OOO is the octal, this, or by X HH, where HH is where O, okay, arbitrary sized bit pattern can be specified by this. Okay, where 000 is 1 to 3 octal digits, and XHH, where HH is one or more hexadecimal digits from 0 to F. So we write define sub. This is 8 plus 3 11 ASCII vertical tab, and this bell 7 ASCII character bell character. Okay, and or in hexadecimal X B is a B is 11. This was also 11. That is good. And ASCII bell character 7. The complete set of escape sequences is this bell character. What is the goddamn bell character? It is not is finished. Okay, print bell.c include stdio.h and main printf a. A is supposedly the bell character somehow. I don't know what that is. Clang print in the output file and then run it, and oh, that is a sound bell. When have I have done this in the past at some point. Dot bell written functions to produce the bell sound. At some point I actually did. I don't remember now. At some point, but I wrote functions to make the alert bell sound. Okay, these are the ways, and we can either specify these numbers in octal or in hexadecimal, like that. The complete set of escape sequences is A for bell. Yes, I wrote the bell character command when I was learning about Linux terminal. Yep. Then the character constant /0 represents the character with value 0. The null character is often written instead of 0 to emphasize the character nature of some expression, but the numeric value is just 0. A constant expression is an expression that involves only constants. Such expressions may be evaluated at during compilation rather than runtime, and accordingly may be used in any place that a constant can occur, as in this. Define this. A constant expression is an expression that involves only constants. Okay, constant expression is an expression that involves only constants. Such expressions may be evaluated at during compilation, okay, rather than runtime, and accordingly may be used in any place that a constant can occur, as in this. We define a constant here, then uh, then an array of characters called line, which has max plus 1, or define leap 1 in years. Int days. Days is a array of integers, and these are the integers that it contains. Okay, and leap is 1. Mhm. Yeah. A string constant or a string literal is a sequence of zeros or more characters surrounded by double quotes, as in is a sequence of 0 or more characters surrounded by double quotes, as in this. This is a string constant, okay, or this is the empty string. This when there are 0 characters. The quotes are not part of the string, but serve only to delimit it. The same escape sequences used in character constants apply in strings escape sequences. Okay, this represents the double quote character. String constants can be concatenated at compile time. String constants can be concatenated at compile time. This is equivalent to that. What the heck? Print bell. Huh, that would be crazy. Huh, it is actually equal to that. I'm getting no errors. What the heck? Let me also write hello and world. Shit, I can provide multiple strings. Hello world. That is crazy. This is equivalent to this. That is crazy. This is useful for splitting up long strings across several source lines. Technically, a string constant is an array of characters. The internal representation of string has internal representation of string has a null character at the end. So the physical storage requires one more than the number of characters written between the quotes. This representation means that there is no limit to how long a string can be, but programs must scan a string completely to determine its length. Must scan a string completely to determine its length. The standard library function strlen returns the length of its character string argument s, including excluding the terminator. Here is our version. Strlen takes in a character string, it starts with 0, while this is not equal to null. We keep incrementing I, and at the end we return I. That is pretty easy. Strlen is other string function, and other string functions are declared in the standard header string.h. Be careful to distinguish between a and a string character constant and a string that contains a single character. This is not the same as this. That makes sense because this just takes one byte, and in that byte has the value for the character x, but this takes pointer that points to a byte which contains the code for x, and it is followed by null character. The former is an integer used to produce the numerical value for the letter x in the machine's character set. The latter is an array of characters that contains one character, the letter x, and a null character. There is one other kind of constant, the enumeration constant. An enumeration is a list of constant integer values. Okay, enumeration is a list of constant integer values, and stream is working fine, and we are at the 2 o'clock mark. What is this? Yes, enumeration boolean. No, yes. Okay, there is one kind of constant, the enumeration constant. An enumeration is a list of constant integer values, as in this. But we do not know what yes and no are. The first name in the enum has the value 0, and the next has the value 0, 1. Okay, okay, is this like is it this like symbolic constant? Somehow the first name in an enum has value 0, and the next 1, and so on, unless explicit values are specified. All values are specified if not all values are specified, unspecified values continue the progression from the last specified value as the second of these examples. This bell has this, and backspace has this, tab means this, new line means this, v tab means this, return means this, and the second January, February, starting from January 1. Okay. Names in different enumerations must be distinct, and different enumerations must be distinct. Values need not be distinct in the same enumeration. Okay, so January and February can have the same value. That is not no problem, but January cannot appear twice either in this or in two distinct enumerations. And what does this name refer to? Okay, let me see. Enumerations provide a convenient way to associate constant values with names, an alternative to hash define. That is what I said, symbolic constant, with the advantage that the values can be generated for you. Although variables of enum types may be declared, compilers need not check that what you store in such a variable is a valid value for the enum enumeration. And nevertheless, enumeration variables offer the chance of checking and so are often better than defines. In addition, a debugger may be able to print values of enumeration variables in their symbolic form. Let's see. In C, the symbolic constants which are defined using hash define are processed by the preprocessor. Mm, when the preprocessor encounters them, it replaces their name, their their symbols with their values everywhere they appear in the program. And but how are enums used in the program and who handles define versus enum in C. You are right. Symbolic constants defined using hash define are handled by the C preprocessor before actual compilation. When the preprocessor encounters them, it performs a simple text replacement throughout the code. However, enum work differently. How enum is used and handled. An enum, short for enumeration, is a way to define a set of named integer constants. An enum, short for enumeration, is a way to define a set of named integer constants. Unlike define, it is handled by the compiler, not the preprocessor. It colors red, green, and blue. And red has the value 0, green has the value 1, blue has the value 2. And then I do go enum colors, my color equal green. Hmm. Enum color, my color equals green. Okay, so I will have to use them in the program like that. It seems how the compiler handles enum. The compiler assigns integer values to each enum constant. If not specified, the first value is 0 and the next value increment by 1. Assigns integer values. The values are only integers. The compiler ensures type checking and scope rules. Unlike define, the values of an enum exist in the symbol table and can be debugged. Who handles it? Preprocessor. Define is handled by preprocessor and compile is handled by enum is handled by compiler. Type safety, no type checking, strong type checking. debugging, hard to debug, easy to debug, stored in symbol table. Scoped like a normal variable can be stored as an integer. Okay, that when defining a set of related integers like color codes, status codes, for type of safety. Okay, so the benefit that I am getting here is I can just write I want this to be equal to green, and I do not have to care about what green value actually is. I can define all of them at one place and then use them by their name, which is pleasing to my eyes. And then if I have to change them later, I can just change them here. Makes sense, makes sense. That makes sense. And where are we? We are at declarations. What did I say I will complete? Till this. Okay, we got this. Declarations. All variables must be declared before use. Yes, although certain declarations can be made implicitly by content. A declaration specifies a type and contain. Although certain declarations can be made implicitly by content. A declaration specifies a type, contains a list of one or more variables of that type, as in this. This specifies that lower contains an integer, upper contains an integer, and step also contains an integer. Then C contains a character, and line contains a pointer that points to a set of 1,000 characters. Variables can be distributed among declarations in any fashion. The list above could well be written as this. Okay. The later format takes more space but is convenient for adding a comment to each declaration for subsequent modifications. Okay. A variable may also be initialized in its declaration if the name is followed by an equal sign and an expression. The expression serves as an initializer, as in the expression serves as an initializer, as in this. Escape will equal to the escape character, I equals 0, limit equals max line plus 1, and float ips equals this. Okay. If the variable in question automatic, is not automatic, the initialization is done only once, conceptually before the program starts executing. And the initializer must be a constant expression. Okay. If the variable in question is not automatic, that is, it can be accessed outside the scope, then the initializer does not initialization is done only once, conceptually before the program starts executing. Yes, because it is not an automatic variable. We are getting that variable from outside, and since we are getting it from outside, it can be treated as a constant. And when we get it, we have to have some value for it. Therefore, it is conceptually initialized before starting the execution. And the initializer must be a constant expression. That is, it can be evaluated at the compiler by the compiler. An explicitly initialized automatic variable is initialized each time before the function or block it is in is entered. Okay. The default initializer may be an expression. External and static variables are initialized to 0 by default. External or static variables are initialized to 0 by default. External or static. Okay. External that use extern, and I can use them from other files. And static variables are variables which cannot be which cannot be accessed outside of my current file. Automatic variables for which is no explicit initializer have undefined, that is garbage value. The value which was stored at their memory location before it was allocated to this variable. The qualifier const can be applied to the declaration of any variable. Okay, to specify that its value will not be changed. For example, for an array, the const qualifier says that the elements will not be altered. So const double equals this and const message equals warning. The const declaration can also be used with array arguments to indicate that the function does not change that array. Oh, that this means that when I give a, a string of characters to this function, this is a const. Therefore, the string will not be altered. The result is implementation defined if an attempt is made to change a const. Is implementation defined if an attempt is made to change a const. That makes sense. Now let's do arithmetic part, operators too. This has been a long stream for C. That is too bright. Yep. The binary arithmetic operators are plus, minus, multiply, divide, and the modulus operator, which gives the remainder. The integer division truncates any fractional parts. Okay, integer division truncates any fractional part. That makes sense. The expression this produces the remainder when x is divided by y. Produces the remainder when x is divided by this, and this zero is thus zero when y divides x exactly. Yes. For example, a year is a leap year if it is divisible by 4 but not by 100, except the years that are divisible by 400 are leap years. Therefore, I'm checking for two conditions. If the year is divisible by 400, then it is a leap year, or if it is divisible by 4 and not divisible by 100, then also it is a leap year. Okay. The modulus operator cannot be applied to a float or double. Cannot be applied to a float or double. The direction of truncation for divide and sign of the result of modulus are machine dependent for negative operands as in the action taken on overflow and underflow. Okay, the modulus operator cannot be applied to a float or double because we might not have the required number of the required number of that those significant bits in the which appear before the decimal place. Then the direction of truncation for divide and the sign of the result modulus are machine dependent for negative operands as is the action taken on overflow and underflow. It depends on the machine. The binary plus and minus operators have the same precedence, which is lower than the precedence of multiply, divide, and modulus, which is in turn lower than unary plus and minus. Arithmetic operators associate left to right. That makes sense. Table 2.1 at the end of this chapter summarizes precedence and associativity for all operators. Okay, that is quite a bit. We have done that, and that is the end of the stream for today. End of